Hello and welcome back. Let us try to understand what is rank of a matrix. So you can look at the definition here. The maximum number of linearly independent column vectors in a matrix or the maximum number of linearly independent row vectors in a matrix. We understood what is linearly dependence and independence in the previous session. So if the maximum number of linearly independent column vectors or linearly independent row vectors number, the count, is known as the rank. Okay, so let us take a matrix A with m by n, a matrix with m rows and n columns. If you find R the number of maximum independent row vectors and C the number of maximum independent column vectors, the rank of A is equal to R if R less than C. That means if number of independent row vectors, the maximum number of independent row vectors is less than the maximum number of independent column vectors, then rank becomes the row, the maximum number of row independent vectors, number of row independent vectors. If columns are less, the column vectors, independent vectors are less, maximum number of column independent vectors are less, then C becomes the rank of matrix. So rank of A is always less than or equal to minimum of m comma n. Okay, if you take a matrix with 5 by 4 or 5 by 3 dimensionality, the rank will always be less than or equal to 3. Rank of that matrix is always going to be less than or equal to 3. If you take a 5 by 3 matrix, 5 rows and 3 columns matrix, the rank of that matrix is always going to be less than 3, because when you find the linearly independent vectors on the column side, it is going to be less than or equal to 3. And it is already less than independent row vectors, right? So the rank of A is always going to be less than or equal to minimum of m comma n, number of rows and number of columns in the data set. Minimum of number of rows and number of columns in the data set. So let us look at a simple example. When you look at a physical mathematical example, right, you'll understand better than looking at the definition. So let us look at that. I've taken a matrix here with 3 rows and 4 columns, and I am trying to form equations and solve. Here this is called as row reduction echelon form. Okay, we keep the matrix as it is and try to play with the rows and columns. Okay, so I shuffled the column 3 to column 1. If you see column 3 1 4 0 and column 1 4 6 2, right, we have shuffled these two. What are we trying to do here? No, I forgot to explain. We are trying to find the maximum number of independent row vectors and the column vectors. Okay, the rank of this matrix is definitely less than or equal to 3, because rows are less. If you find the independent vectors, it may reduce. It may be equal to 3 or less than 3 independent row vectors. Okay, so I shuffled the C3 and C1 so that I get 0 here, and then what I did is I have taken R2 is equal to R2 minus 4R1. I am trying to eliminate the values, or I am trying to make some of the values 0. Why am I trying to make some of the values 0? If you can multiply one vector with the other and subtract it from the or add to the other vector, if you are finding a 0 vector, right, that means this vector is dependent on other vector. If you eliminate the dependent vector, then the remaining vectors become independent. If you see here, right, we don't know which row vectors are independent here. So if you do some mathematical operations and you can eliminate one row, that means that row is somehow dependent on the other row vectors. So then you will know the independent vectors. So that's what I am trying to do. So this is called as row reduction echelon form. I have taken the second row and trying to subtract the first row by multiplying with 4. R2 minus 4 into R1. Okay, second row I have taken and multiplied with, so here second row, and multiplied the first row with 4. So I got 4, 8, 16 and then 12, right? When I subtracted this one from this one, what happened? 4 minus 4, 0. 3 minus 8 minus 5. 6 minus 16 is minus 10. 7 minus 12 is minus 5. So I have got 0, minus 5, minus 10, 5. I took the second row, multiplied the first row with 4 and try to subtract, because I am trying to eliminate it. No, I am trying to eliminate the numbers here. I am trying to make them 0. When I am successfully able to make complete row 0, that means that row is dependent on other rows. Okay. Now if you look at this, if you look at the fourth row and the third row, third row and second row, if you multiply the third row with 5 and add it to second row, you can make either second row 0 or third row 0. I chose to make the third row 0. It doesn't matter, right? Because we want to find the independent vectors. So R3 is equal to R3 plus R2 by 5. So if you divide this by 5, right, it becomes 0, minus 1, minus 2, minus 1. When you sum up these two, you get 0 vector. So this third vector is somehow dependent on the other vectors. Okay. So we eliminated the dependent vectors. So we have got independent vectors. So 2 maximum number of independent row vectors are there. And independent column vectors, how many? 1, 2, 3, 4, because non-zero vectors are there after doing the row reduction echelon form, right? So they are independent vectors. So 4 is less than 2, so rank is going to be 2. So after row reduction echelon form, we have 2 independent row vectors, 4 independent column vectors. Hence the matrix rank becomes 2. If you look at the definition here, the rank of A is equal to R if R less than C. The R is the maximum number of independent vectors, independent row vectors. So that's how you actually find the rank of a matrix. The maximum number of independent row vectors or column vectors, whichever is minimal. Okay. Thank you.